This is the second of, I'm assuming, more than 2 videos for the instructional worksheet 9.2. And in this video, we'll be discussing energy transformations. No one makes energy. It comes from somewhere. No one really uses up energy. It has to go somewhere. Remember, the law of conservation of energy says that energy is not created or destroyed. But when we burn up the gas in our car, it's gone. Where does it go? I love this diagram right here. It tells us wood can be burned to make electricity, wood can be used to make light, and then it says it can be used to make more wood. So if we take a look, wood makes fire, runs a generator, makes electricity, makes light. This is thermal energy, mechanical energy, electrical energy, radiant energy, and chemical energy. This diagram might lead us to think that energy can change from one form to another perfectly, but it's not true. We always lose some of our energy to something like friction, and that's especially noticeable for us in cars. Remember that most cars run in the vicinity of 30% efficiency. There are a number of types of energy. Let's look at these. Here's chemical energy, and that's stored in chemical bonds. Food, plants, batteries. Also, you can think about the gasoline in your car. Another example of energy is thermal energy, and that's heat. Many transformations end up producing heat. Think of, for instance, a toaster or an oven. Nuclear energy, my favorite, is energy from radiation, which would be decay, fission. Or another type of nuclear energy is fusion. That's what happens on the sun. And both fission and fusion make ginormous amounts of energy. Mechanical energy is energy of motion or position. So mechanical energy is kinetic and potential. Kinetic energy, which we've studied in great detail, and potential energy both make up mechanical energy. Mechanical energy is characterized by one important thing: it can become work. Electrical energy, you're all very familiar with, is energy literally from moving electrons. Radiant energy is what really started everything here on Earth. It's electromagnetic radiation from anything. It can be from light bulbs. Our most important source of power, the source of power on Earth, is our sun. In the back of the room, there is an electromagnetic spectrum with all the different types of radiant energy. Let's talk a moment about efficiency. This is a super simple calculation. Input work is always less than output work, and friction always takes a portion of work. Remember, a perfect machine would be 100% efficient, but that doesn't exist. Cars, this says they're about 15, but I say they're about 30. Bicycles are around 95% efficient. Please look at the calculation. Efficiency is equal to output work divided by input work times 100. Remember, input, is that right? Input work is always less than output work. Efficiency equals the work divided by the output divided by the input, multiplied by 100. We're not going to think about this right here.
Also, do you happen to know where Vickers is?
So that's what, let me look at this here. Output divided by input. And this is backwards. It should be output because we're not 100% efficient. And if it was the other way around, when we're looking at this would be the wrong calculation. Yep. Output is always less than input. And we're done.